Hi, I'm Sean Gaina, and this is Minute Math, and today we're learning about Rolle's theorem.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals x squared minus 2x minus 15 over a negative x plus 6, and we want to find the values of c that satisfy Rolle's theorem on an interval from negative 3 to positive 5. Now, luckily for us, our function is continuous on a to b. The only issue that we would have is when x is 6 here, because the denominator would equal 0, but it's outside the interval. Same thing with it being differentiable. Same issue, but we're fine there. If f of a is equal to f of b, we're good, and I found them for you. F of negative 3 is equal to 0, and f of positive 5 is also equal to 0. From there, we can apply Rolle's theorem. We need to take the derivative. So f prime of x, using the quotient rule here, derivative of the numerator, 2x minus 2 here is the derivative of the numerator, multiplied by the denominator, negative x plus 6, minus derivative of the denominator, negative 1, times the numerator, x squared minus 2x minus 15. All over a good old denominator squared, negative x plus 6, all squared. From there, let's go simplify what we can. We're going to be multiplying things out here. Multiply these together. 2x times negative x is a negative 2x squared. 2x times 6 is a 12x. Negative 2 times x is a positive 2x. And negative 2 times 6 is a negative 12. These negatives cancel to be a positive, and so we just have a plus a x squared minus 2x minus 15. All of that is good over the good old negative x plus 6 squared. From there, let's combine our like terms. Some of these steps here, but it's be worth it. Negative 2x squared plus an x squared is a negative 1x squared. Got them covered. The 2x and the negative 2x cancels each other out, so we just have a plus a 12x here. Got that down. And then negative 12 minus 15 is a negative 27. All of that over this negative x plus 6 all squared. Keep on going. I pulled out a negative in the numerator, so we have a negative out here. X squared minus, if I can do my math, minus 12x plus 27 over a denominator, which is the negative x plus 6 all squared. Keep on going, and that does factor out, and we have that factoring to be an x minus 9 times an x minus 3 over a negative x plus 6 all squared. Now, Rolle's theorem states once we have a derivative, we just set it equal to 0, so let's go do that, and we define the c values with x values here. Now, we only really care about our numerator. Our denominator really just causes anything to be undefined, so the numerator, we just define when that is equal to 0, and then we're good. So we take our numerator, our negative x minus 9 times an x minus 3, set it equal to 0. Divide both sides by a negative, doesn't really matter, because 0 is over there. We set both parts equal to 0. X minus 9 equals 0, x minus 3 equals 0. So we have x equals 9 and x equals 3. Now, be careful here, x equals 9 is not within my interval, so we don't count that one. 3 is the only one within the interval, so a c value of 3 is the value of c that satisfies Rolle's theorem here. Hope this video is helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.